All right, let's do a boat and plane example. So let's go ahead and make the river. The river is flowing down. And again, none of the numbers actually matter, right? So we can make the river flow down at 2 meters per second. And let's say you're over here and you're in a boat. Okay. And let's say the boat's maximum speed is 18 meters per second. Okay, it's like 40 miles an hour. Okay, option one, the boat could head straight across. Okay, so the boat points straight across. Well, that doesn't mean he's gonna go straight across, right? So the boat's gonna go this way, but the river's gonna push him down, and he's gonna end up over here. Let's say the river is, and again, I'm just gonna make this easy for us, 180 meters wide. Okay, that's the horizontal distance. Okay, so if I just point straight across, then in the x direction, the river's vertical velocity does not influence the boat's horizontal velocity. And so if you think about this, it's just 180 meters traveling horizontally at 18 meters per second. It's going to take me 10 seconds to cross. Vertically, well, that's just this. If I'm vertically going 2 meters per second for 10 seconds, I'm going to drift down 20 meters. Okay, so in scenario number one, the boat just points straight across and doesn't correct for the river, then the boat's its horizontal velocity is always just 18, and so horizontally it's going to travel 180 meters at 18 meters per second. It's going to take 10 seconds to cross. Vertically, it's going to be going 2 meters per second, drifting down for 10 seconds. It's going to drift down 20 meters, and the boat's going to end up down here. Okay, option two. Again, this is where the boat was pointing straight across. Now we want to actually go straight across. Option two, go straight. Which means really then the boat is going to have to point a little bit upstream. And so the question is, how much does the boat have to point upstream so it doesn't float down? Well, you want the y component of velocity to be 0, right? Because if Vy is 0, then you won't float down or up. And so what we need is we need our boats up. Our boat's going to be 18. Our boat's still going to go across the river, but our boat is going to point up the river. But we know if our boat points up the river at 2 meters per second, that boat up will cancel the river down 2, and then I won't go up or down. And so I'm going to figure out the angle. And so if you look at this, this is opposite and hypotenuse. So sine of theta is 2/18. So theta is inverse sine of 2/18. Okay, so let's see what that is, right? Sine inverse of 2/18 is 6.38. 6.38 degrees upstream. That will make that 2. Now, the other part is, what is Vx? What's my new Vx? Well, I can just do the Pythagorean theorem, right? Vx squared plus 2 squared equals 18 squared. So in this case, Vx squared, 2 squared equals 18 squared. Clearly, I had to slow down horizontally, right? I had to use some of my boat's velocity to counteract the river. 17.88, let's round it to 17.9. Okay, so I had to use some of my boat's engine power to compensate for the river, which left me crossing it not as fast. If I wanted to find the new time, well, it'd be the same thing, right? I'm still crossing a 180 meter river, but now I'm only crossing it at 17.9, and I can solve for that time. And again, it's going to take me a little bit longer. And the bigger the current, well then, of course, these, the bigger effects. So now it's going to be 10.05 seconds. Again, this is such a small current that I don't really have to point it up much, and I don't really actually lose much. But the stronger the current, the more you have to point up, and so on. Okay? So the question is, well, what if I actually point at some bigger angle? Or what if I go at a different speed? Okay, option 3 on this question. Okay, what if I told you that my boat is only going to go 10 meters per second, and I'm going to point upstream, or I'm going to point upstream at an angle of 15 degrees. Now the question is, what actually happens? Option 3 on this question. Do I go upstream? Do I go downstream? I could actually go straight across. I don't even know. I just made up these numbers. There's a chance that the vertical component of this is bigger than 2, equal to 2, or less than 2. Let's just figure it out. What I'm doing is I'm just giving you the magnitude 10. I don't know how fast this way, and I don't know how fast this way, but I'm giving you this angle is 15 degrees. So if I want to find Vx and Vy, all I have to do is do what we always do. Vx is going to be 10 cosine 15. Vy is going to be 10 sine 15. Those are just numbers. So let's type those in. 10 cosine 15 is 9.66. And Vy, 10 sine of 15 is 2.59, again, meters per second. So if my boat pointed up at 15 degrees, again, this up, when I say that means upstream, above horizontal at 15 degrees, and my boat was only going 10 meters per second, what happened is that I would be crossing the river horizontally at 9.66 meters per second, and then my vertical velocity of the boat would be 2.59. So, do I go upstream or downstream in this scenario? Well, upstream, of course. Look, the vertical velocity of your boat is bigger than the vertical velocity of the current. You end up with a net vertical velocity up, and so over this time period, you're going at 9.66, but you're going up at 0.59. So you're going and you'd end up here. So 3 different scenarios. Here, no compensating for the river. All your boat is horizontal. All your vertical is river. Down here. Here, I figured out the angle, the perfect angle, 6.38 degrees, that if I point my boat upstream like this, I actually will go, and I'll be pointed upstream, but I'm going to be going like this. Nothing will be going up or down because my up of my boat is equal to the down of the river. And in this scenario, I just gave you a random speed and a random angle, and I just said, okay, what actually happens if you do this? Well, pointing your boat at that angle with that speed leads to these components. I now know that I'm crossing, well, I guess 180 meter and about 9-ish. So it's going to take me about 20 seconds to cross. And since this is bigger than the river, I actually will float up. Or not float up, my boat will actually go up. I'm not really sure what other options there are, right? I can give you something random, I can ask you to go straight, and then I can actually say, okay, you just point straight, and what do you do? Hopefully you understand that if this was a plane with wind, it's the exact same thing. I know in class we said like, hey, there's your velocity of your plane, and this is some velocity vector of a wind. And I said, okay, what's the combination of those things, right? And then you say, well, I could just add those tip to tail and get an idea. So that one's up, right? There's like a coordinate system, right? That one's all up, and that one's, what, a little east or a lot east and a little south. So it's going to slow me down north and south, but it's going to speed me up east, and the resultant is going to be some like this guy that looks like both of them together. And if you want to know whether you sped up or slowed down, you could look at the magnitude of the original vector and then of the resultant. Okay? Hopefully this helps you with the boat and plane situations.